Hi, welcome back to Mrs. Thompson's classroom. Today we're going to continue talking about matrices, and in particular we're going to talk about Cramer's rule. Now Cramer's rule is a method of solving systems of equations developed by Gabriel Cramer, or named after him, a mathematician from the 1700s. And it states that every variable can be found by forming this ratio of two determinants. So the question is, what is matrix A and what is matrix AX, AY, and so on? Well, A is just the matrix of coefficients. So we're going to take just the variable part and form a matrix of the coefficients, and then we're going to find its determinant. So the coefficients from the first equation are 2, 1, negative 1. And we have 1, 2, and 3. And 3, negative 2, and 1. Okay, now we're going to find the determinant. So I'm going to use just the diagonal method for doing this. So the first diagonal is this 2, 2, 1. So 2 times 2 times 1 is 4. Then I'm going to take the next diagonal, which would be 1, 3, and then it wraps around. So 1 times 3 is 9. And then the last one starts here with the negative 1 and wraps around. So I have negative 1 times negative 2, so that's 2, and I add these together. Okay, then I'm going to go and do the upward diagonals. So the first upward diagonal goes down the center of the matrix there, and I get 3 times 2 times negative 1, which is negative 6. Okay, then I'm going to go to the negative 2 here, and I'm going to find its diagonal, which will wrap around. So I have negative 2 times 3 times 2, so that's going to be a negative 12. And then finally, I come here to the 1, and I form its diagonal, which wraps around, and I get 1 times 1 times 1. Okay, and I add these together. And then I do the downward diagonals minus the upward diagonals, and I get 13 plus 2, so that's 15, minus, and inside here I get negative 18 plus 1, that's negative 17. So all together that's going to make 32. Okay, now we have to find each of these other determinants, one for each variable. So A sub x is going to take the answers, the values on the other side of the equal sign, and replace the x column. So instead of 2, 1, 3, I'm going to put negative 1, 8, and 4. And then I just rewrite the y column, and I rewrite the z column. Okay? And I find the determinant of that. A sub y is going to take these values here, and instead of replacing x, it's going to replace the y. So the x column will be left alone. The y column will become negative 1, 8, and 4. And then the z column will be left alone. And I find that determinant. And then I do a sub z. And a sub z is going to replace the z column. So I'll leave the x's alone. I'll leave the coefficients of the y's alone. But I'll replace the z values, the z coefficients, with those numbers on the right side of the equal sign. And then we find each of these determinants. Now, we can do the diagonal method again, or we can get our graphing calculator or the computer and calculate them that way. Okay, so using the calculator, again, you can go to your matrix menu and you go to math and use the option 1, which is determinant. So I'm going to do the determinant of a sub x. And so this will give me 20. Then I can put in a sub y, and that one's going to give me 4. And I can put in a sub z, and this will give me 76. Okay, so then I can find these ratios. So x is going to be 20 over 32, which will reduce down to 5/8. Y is going to be 4 over 32, which does reduce down to 1/8. And then z is going to reduce down to 76 over 32. And 76 divided by 32 reduces down to 19/8. And so I have solved for all 3 variables. Okay. So this is just a method for solving systems. There are a variety of them. One of my earlier videos looked at Gaussian elimination. And so that's one method. And in the next couple of videos, we'll look at finding inverse matrices and using those to solve systems. But it's just one way that we can use, in particular, use our technology to solve our systems of equations, because they'll do the determinants for us and the Gaussian elimination and so forth. So hopefully you'll join me again next time to talk about inverse matrices. In the meantime, get some practice at doing these. If you're in class with me, be sure to complete your worksheet and let me know if you've got any questions. Feel free to comment below. Have a good day.